Welcome back for Lesson 4 of the Java Puzzle Ball MOOC. My name is Nick. I am a game designer and senior curriculum developer at Oracle. We'll cover Lambda expressions in Lesson 4, which means things are going to get a bit more technical. For Lesson 4-1, I wanted to go behind the scenes of Java Puzzle Ball again and explain what it was like designing the Lambda game mode puzzles. Because I'm often asked, what was it like making a game at Oracle? They make games? I make them, Oracle not so much. Java Puzzle Ball was originally intended for two Oracle University courses, Java SE8 Fundamentals and Java SE8 New Features. New Features focused heavily on Lambda expressions. I knew I needed to make Lambda puzzles or maybe even a new game to teach Lambda expressions, but I didn't know what this was going to look like. Lambda was mysterious. Basic and inheritance puzzles were developed without a design for Lambda. I made art for Lambda wheels and bumpers not knowing how I'd ever use them. I started by researching Lambda expressions and thinking about aspects of the game I wanted to improve. For example, in basic and inheritance puzzles, once you set the ball into motion, all you do is wait, and I wondered, could there be more interactivity? Some testers thought they weren't learning if they weren't typing Java code. Now, Pig Pounder shows how this way of thinking can be dangerous, but I still wanted to see if Java syntax was a direction I could innovate. And finally, I wanted to destroy stuff. If you can turn the ball into a blade, can you ever slice Duke with the blade? If not, it's probably just a big tease. So what did I propose? I made a pitch at the beginning of February 2014. Lambda puzzles are different. You're not designing classes anymore, but I want to extend the existing ball, bouncing, and bumper code. One way I learn is by messing around with settings and then observing the effects to gain insight into what that portion of code controls. So Lambda puzzles let you edit the values in Lambda expressions, click the ball as it moves to change its direction, and filter away or destroy blue bumpers. This will make more sense as you play. The reason this works for Lambda expressions is when you have a program with a lot of instances, whether that's a lot of bumpers or bank accounts, you often need to search, compare, and filter those instances based on their properties. For example, a bank may want to award a $20 monthly bonus for every account with at least $20,000, charge a fee for every account that hasn't posted enough transactions in a month, or maybe you get fed up with their fees and you want to search for every account under your name so you can close them. Performing these actions involves examining account object fields, like balance, number of transactions, account owner, and Lambda expressions are very good at handling this logic. Lambda puzzles let you perform actions and filter bumpers based on their properties. Bumper properties include shape, color, number, that's a new one, with the ultimate goal being remove all blue bumpers from the field of play. However, this caused an issue for colorblindness. Previously, all blue bumpers contained rectangles and all red bumpers contained stars. If you couldn't tell the difference between blue and red, you could at least tell the difference between a rectangle and a star. Lambda bumpers wreck this convention by mixing colors and shapes. Here's what I mean. Let's say you're colorblind. Can you tell the difference between the blue and red bumpers? No, and that's the problem. So, what's the solution? How do players remove blue bumpers if they can't tell what's blue? To address this, we added a glow effect around blue bumpers. Now blue bumpers stand out. This is what's called software accessibility. You want to make software as accessible and usable to as many people as possible. All of this took about 1 month to develop. Because it was tied to Oracle University Java SE8 New Features, which has an advanced audience, it assumed players already came understanding a few additional things about Java syntax and Boolean values. I'll explain these right now, and then let you play the Lambda puzzles. Comparing values requires special syntax called logic operators. Here are some you'll encounter while playing. Equals equals checks to see if one value is equal to another. Exclamation point equals checks to see if one value is not equal to another. Sometimes you'll need to compare several values. And is used to check to see if this value and that other value both equal something. or checks to see if either this value or that value, just one, equals something. These are combined with equals equals or not equals. As you play, try to discover more about how these operators work. I thought this quick explanation would be good to help you get started, but remember, a goal of this course is to learn by playing around and exploring. So, play Lambda puzzles 1 through 7. You're welcome to go beyond Lambda puzzle 7. As you play, can you identify use cases for Lambda expressions? Do you develop a better understanding of logic operators? When you're finished playing, move on to the next part of the lesson.